Okay, hello everybody, and thank you for joining us in our presentation about our Mountain View High School robotics team. My name is Kenneth, and today I am joined by Matthew, Vinay, and Laura as we explain the process of our team. So hello, my name is Kenneth. I've been on the team I'm going into my fourth year on the team, and I'm mainly involved in mechanical.
Hi, my name is Matthew. I'm going into my third year on the team, and I'm also involved in mechanical.
Hi, my name is Vinay. I'm going into my third year on the team, and I'm primarily involved in software.
Hello, my name is Laura. I'm going to my second year on the team, and I'm primarily involved in mechanical and entrepreneurship. Our team participates in the FIRST Robotics Competition, also known as FRC. The acronym FIRST represents for inspiration and recognition of science and technology. In FRC, we compete under strict rules with limited time and resources. This unique environment challenges both students and mentors to work collaboratively to design, build, and program washing machine-sized robots. These robots will then compete in a game which changes from year to year against other FRC teams from across the world. Our school, Mountain View High School's FRC team is Team 971. Our team name is Spartan Robotics. 971 is a team number we were assigned by FIRST at the start of our rookie year in 2002. Currently, our team has about 30 students and 20 mentors. With all the hard work from within our team and with the support of our sponsors, some examples of them are NASA, Google, ORIS, Abbott, Lockheed Martin, SolidWorks, we are able to compete annually in about 6 competitions.
Every year, we get a new game that is generally played on a 26 by 54 foot field with an alliance of three 120-pound robots. This is our 2019 robot, nicknamed Tachyon, that we designed for the game that year. The objective of the game was to put the orange balls seen in the picture inside the cargo ship and rockets, and then to place a hatch on the hull. At the end of the game, robots could choose to either not climb at all or climb to level 2 or 3, with 3 being the tallest and scoring the most points. In that year's game, we finished 4th overall. So this is our 2020 and 2021 robot that we nicknamed Napoleon. It was designed to compete in the Infinite Recharge game, where the objective of the game was to shoot dodgeballs into 1, 2, or 3-point goals, as well as to climb and hang on a bar at the end of the game. While we haven't gotten a chance to compete with this robot at competition yet, we have used it in FIRST at-home challenges where we were finalists.
Our team meets year-round, beginning with the official season, which goes from January through April. The official season begins with kickoff, during which the team gathers to watch FIRST reveal the year's game, and we begin planning our robot then. During the season, the team splits into specific groups to manage the various subsystems that are developed for the new robot. The robot is then developed in CAD and then built, preparing the team to compete at regional qualifiers to qualify and attend the championship competition. After the championship, the team goes into the off-season from May to December, in which we build the third robot, which is named that because we build twin robots during the season. The third robot is a learning opportunity for newer members that join during the summer in the beginning of the school year. The off-season allows for the team to embrace these new members and provides countless opportunities for members of all grade levels to advance their skills.
So now we move on to our prototyping CAD stage. And during this stage, we always start with brainstorming models and ideas of what features are necessary and what features we want. We first thoroughly research our game for that year, and based on the requirements and goals for the game, we start to list out different robot iterations to solve each in-game objective. After we gather a strong list of options, we filter the iterations until we are left with the most efficient and effective solutions to solve in-game obstacles. After we determine feasible results, we first use Crayola CAD either in SolidWorks or Onshape to construct a 3D model draft of what we are building based on the ideas we discussed. Since we don't know which robot model is the best, we prototype different features on the robot to observe which one is the most compatible. During the prototyping stage, we manufacture our desired models based on our CAD using wood so that we can manufacture and assemble them easier without wasting resources and still produce accurate results. So this is an example of the prototyping process of our 2020 to 2021 robots shooter, also known as the Napoleon shooter. So first, we prototyped the basic version of the flywheel to see if we can go forward with this idea on the very left-hand side of the picture. And then after we did determine that it was a good idea, we experimented with different surface in the flywheel on the hood and the hood compression, just change different variations. And additionally, we added a tower to see if that increased accuracy. After that, we made different wheel configurations to optimize energy transfer between the motors. And after all that was finished, we started to collect data and gathered over 4,000 ball shots over 10 distinct shooter variations. So these are the CAD images of our shooter prototypes of the 2020 to 2021 season. And while there are many different shooter iterations on this slide, these are not all the prototypes we have designed that year. Additionally, from all these designs, only one is implemented on our robot.
So after we finish creating a CAD model for a part, the next step is to fabricate that part. We use a variety of machines to produce parts, including industrial grade CNC mills and routers, as well as 3D printers and lathes. We also do this under time-sensitive conditions, which prepares us for the real world, where there's constant pressure to perform to expectation.
Our team has an incredibly advanced software team. We use industry standard tools to build and deploy our code. This includes, but is not limited to, using Git and code reviews and a re-implemented robot operating system to build and power the software components of our robots, which range from vision systems to autonomous systems. We even open source our code on GitHub, making software more accessible to other FRC teams and even major companies that use our code. Although it is one of the most challenging aspects of the team, the industry professional mentors, many of whom built this team software when they were students at Mountain View High School, collaborate and guide students to maximize their coding potential.
So after software, we move on to competitions. And these competitions are hosted after our 6-week build season in the month of March. And they are often very competitive and fast-paced, since around 30 to 50 teams come to one field to compete within 3 days. Our team often goes to 2 regional competitions, one in Silicon Valley and one in San Francisco. However, if there are competitions that are filled, we fly to other states to compete. If we place first in one of the competitions or earn a qualifying award, we qualify to attend the championship event in Houston. However, in order to achieve promising results from these competitions, a major part which contributes to our success is from scouting and strategy in our team. These groups scout different robots during a competition using our team's integrated scouting website to record data. After we receive this data, we process the information and form strategies based on which robots from different teams perform well and which robots we want to recruit on our alliance. Although this portion sometimes gets unrecognized, it is a very essential part which helps us place well in competitions. So for the championships, after our typical regional challenges, if we qualify for the championship tournament, we go to one of 2 challenges hosted in either Houston or Detroit. We go to the Houston competition to compete since it is in our regional division. In this round robin tournament, there are 6 fields to play on, and the team that places first in each field moves up to the Einstein's competition, which consists of the 6 teams that place first and decides the world champion. These championships are well known and attract many teams from not only the US, but around the world. Our team has a strong history of often qualifying for these Houston championships.
In order to compete at this level, we divide responsibility and tasks through our leadership structure. In our team, we have lead mentors who work with student leaders in order to lead the different subgroups. The subgroups of our team are hardware, software, competition, entrepreneurship, and manufacturing. A little bit more about entrepreneurship. This is where we use our platform and our strengths to help out others in the FIRST community. We also reach out to educate our community about FIRST and STEM in general. We mainly do this through robot demonstrations, presentations given at elementary schools, middle schools, sponsors, and through community events.
So our team has a long history of alumni returning to mentor the team. Many of our alumni come back as either adults or college students and take skills they've learned from other teams and companies to help better our team. Additionally, our team has had 4 Woody Flowers finalists, which is a mentorship award for excellence that FIRST mentors are eligible for.
Our team strives to make robotics accessible and enjoyable for all students, while also competing at a high level in FRC. All students are encouraged to pursue the numerous opportunities that are given to them, and our goals are at the forefront of our endeavors and the basis for the team's incredible successes. These are a few pictures of past robots that the team has created. As you can see, they all vary in size and shape, conforming to the needs of that year's game. While the past year was challenging, our team has continued to grow. And thanks to tremendous support from our community, we are looking forward to moving into our newly constructed lab at Mountain View High School in the coming weeks in a normal competition season. Thank you for listening, and this concludes our presentation.